What's up guys, Connor here back with another video. Today we're going to be showing you how to find the limit as x approaches a certain number in calculus. So what's going to happen first is Ms. Luxton's going to give you a certain equation, like so. And with this we're going to be finding what the limit is as x approaches -2. So what you want to do first is you want to plug -2 in for every x in the equation. Plugging in. So we put -2 in for all the x's. So when we get to this stage, all we're going to do is just solve. So 2 times -2 is -4, plus 4 is 0, and -2 plus 2 is 0. This means that we have 0 over 0, and there is no value for x at -2. So the point is undefined. Now what you might be thinking is, oh no, this is bad, I don't know what to do, oh crap, I'm gonna have to do more math, but don't worry, we can figure it out. So if the initial plugging in method didn't work, what we can do is algebraically we can plug in numbers that are very, very close to the actual x value that we're approaching. So instead of -2, we're going to plug in -2.0001, and what we end up with is 2.0009, and then we're going to do it from the other side as well. So we're going to plug in -1.999, and what we end up with is 1.999. So with the two values we found in 2.0009 and 1.999, we can almost be certain that the limit that we're approaching is 2. But this isn't the only way we can look at it. We can also look at it through a graph and a table. To look at this graphically, we're first just going to put our initial equation, not counting the limit obviously, just this, into our grapher and see what we get. So after putting our equation into the grapher, we can look at the graph and see that it pretty much just resembles the equation y equals 2. And you can't see a hole in this graph, but there's multiple things you can do to check if there is a hole. So the first thing we can do in looking at our grapher is to trace a few numbers. So we can do this by hitting trace. And why don't we just type in some numbers that are very close to the -2 value that we're looking at. So we can go trace and then -1.999. Obviously we're going to get 2 on the grapher. Then we can trace -2.0001. Enter that in. We're going to get 2 on the grapher. Then when we actually trace what we're approaching, which is -2, trace -2, there is no value for y. So the next step is just to go over to the table and look at that. So the first thing you want to do is go to table set, which is just right here, and just you're going to want to make the number that you go up by in your table very, very small so you can see the really slight change that happens. And obviously I started at a number that was really, really close to -2, which is -2.003. So now we're going to go over to table, and as we can see, there's an error at -2 with everything around it being 2. So this tells us that we have a hole in our graph after all. So when we finally look at our graph, this is what it's going to look like. It's just a straight line, but at -2 you can see that there's a hole, and this just means that it approaches this number, but there is no actual value at x equals -2. And then we can look over at our table that I made, just the same as what was on the grapher. For the f of x, it's just 2, 2 all the way, except for at -2 we can see it's undefined, and then just increasing by very small numbers on the x side of the table. So in conclusion, the limit as x approaches -2 for the equation 2x plus 4 over x plus 2 equals 2. in calculus, you're going to get a lot more confusing problems than this one, but if you follow these simple concepts and steps, you'll be able to just slowly work your way through any problem that comes your way.